Hello friends, today I will show you how to use SpringAI and OpenAI embedding model to generate embeddings for your own dataset. And turns out this is one of the most common questions, at least on my channel. Some time ago I released a video demonstrating how to use SpringAI and the PostgreSQL pgvector extension to build the scalable GenAI applications. And many of you asked me, hey Dennis, yes, you showed how to build this app from scratch, but how exactly did you generate embeddings for your own dataset? And today I'm going to answer this question. So let's not waste a minute and do a deep dive. As always, we will begin with a sample application, and especially this part will be useful for those who has not watched my first video on SpringAI and Postgres pgvector. This sample application is called Yuga Plus. It's a movie recommendation service that takes questions in plain English and provides you with various movie recommendations. And presently the application relies on the Postgres full-text search capabilities to come up with those suggestions for you. How it's implemented, I have this controller, and the controller supports the search method. You need to send the request and provide your prompt, your question, your ask, and then you also can be more specific. You can say that you are interested in movies with a certain rank, and also you might pick one of those movie categories. After that, the application will generate a SQL request that will return you a list of movies, including titles, overview, vote average, release date. And this part of the request performs that full-text search over your data. This is how you do this in Postgres. We are not going to discuss it today. Probably that deserves a separate video. So now let's see how this application works, because we will start from here, and then our goal would be to replace this full-text search implementation of the app with a similarity search using pgvector and embeddings that we need to generate. First thing first, I need to start my backend. Spring Boot run. The backend is up and running, which means that we are good to go with the front end. npm start. It's up and running on the following address. Jump into my browser and head into the application UI. First we need to sign in. Yes, my friend, I took care of the security at least a little bit. That's the application interface. It's not sophisticated but minimalistic. This is exactly what I need for my movie recommendation service. Now, let's say that I want to watch a few movies, and I'm giving some pointers. Galactic, Empire, and I think that some of you already guessed it right. Star Wars. Let's make something more obvious, like Darth Vader and Jedi. Okay. We are getting another list following this prompt. However, the full text search capabilities are quite limited. All these words that I type in here must be in the description of your movies. For instance, if you have some misspelling, like instead of saying Darth, you said Dart, let's remove H from the end, you are getting this exception, no movies found, okay? And how about even more sophisticated question? A long time ago, in a galaxy far, far away. You remember this beginning of every Star Wars movie. You're getting this one, and obviously you will not find it. And if you want your application to make sense of questions like this and provide various recommendations, you need to use LLMs. And you need to perform the vector similarity search over your data. Now, let's go and generate embeddings for this movie's dataset. Do you know what's the most crucial step in the embeddings generation process? No, it's not coding or fine-tuning your model. First, you need to select a subset of your data that you want to translate to vectors, to those embeddings. And second, you need to decide on an embedding model, because these days there are many LLM providers out there. Let's start with the data. I'm connected to my Postgres instance, and this Postgres instance is used by this movie recommendation service. Going to the tables, here is my movie table, and the movie table comes with 25 columns. If you scroll down, here is you will find the title, you will find the overview. This column, overview exams, is of the TS vector type. This one is used for the Postgres full text search. And why don't we use the same overview column for the embeddings? It's a good choice. Opening the query console, and let's take a look at a few samples. Also, I want to take the title and overview from movie. Let's get 3. Take a look, that's the title and that's the overview. This is a wonderful choice for the embeddings generation. And moreover, you can take title plus overview and you can generate an embedding for this combination. The next step is model. I already gave you a hint in the beginning of this video that we are going to use OpenAI today. But the OpenAI is not the only choice, just keep this in mind. However, for the sake of this video, we are going to explore the OpenAI capabilities. Jumping back to my browser and heading to the OpenAI embeddings documentation. My assumption is that you understand what those embeddings are, but as a quick context, embeddings is a mathematical numeric representation of your original data. The goal of an embedding model is to take your original data, such as the user prompt, and then generate embeddings, an array of floating point numbers. OpenAI supports several models. The very first one was text embedding ADA 002, but these days it's considered legacy. It's not deprecated, you're still fine to use it, but it's not recommended. Alternatives are these: the latest 2 models, text embedding 3 small and large. The large one is more capable of, it was generated with more parameters, and the small one is basically smaller. When it comes to the large model, by default it generates embeddings with 3072 dimensions, while the text embedding 3 small one generates arrays with 1536 dimensions. And the cool thing, you can change the number of dimensions. If you use the large model with these 3000 dimensions, then you're going to get the most accurate results. And the question is, if you want to be the most accurate, should you go for this model? Not necessarily, my friend. It can be more than enough to use the same embedding model, but asking it to generate vectors with 600 dimensions or 300 dimensions. It's all use case specific. However, today I will go for the text embedding 3 small model, and I will be using the default number of dimensions, 1536. As long as I have already made my choice, the time has come to create a column in my database that will be storing those embeddings. How do we add a column? So we need to use alter table movie, add column command. The name of the column is gonna be overview vector, and the type is gonna be vector, and the dimension is 1536. The number of dimensions must be the same as the dimension that is generated by your model. Creating it, and if we scroll down here, you will find this column. Now we will jump back to Visual Studio Code and we'll use SpringAI to generate embeddings using that OpenAI embedding model, and the generated embeddings are gonna be stored in the overview vector column that we have just created. First thing, you need to go to the PAM XML file and add the SpringAI dependency. At the time of the recording, I was using this version of SpringAI, but check it out, you might be using a different version where you will be watching this video and reproducing the steps on your end. The next step, go to the application properties file. You need to define a few SpringAI and LLM related parameters. All the parameters start with SpringAI, and then you need to define the name of your LLM provider. I am using OpenAI API key, and this is what I need. You can define this OpenAI key within this application properties file, or you can pass it as an environment variable. And I would pass it as an environment variable. I don't want you to see my API key, and also I don't want you to share your API key with anybody else. That's why the best practice is to define this property via an environment variable or by some other more secured means. The other parameter, we need to define the name of our model. What we do, SpringAI, then we are also saying that we are using OpenAI, and then we need to define this one, embedding model options. I'll pass it as this. We are going to use this text embedding 3 small model as we discussed earlier. So from the configuration standpoint, we are good to go. We updated our PAM.xml file, we have added the SpringAI dependency, and also we define these two important parameters: your OpenAI API key, you need to create one if you don't have, and the name of our embedding model. Now we will create embeddings generator that will be reading movie overviews from the database, and then it will be generating embeddings for those movie descriptions, storing them back into Postgres. What do we do? Going back to my backend implementation, and I will create embeddings generator class. The implementation is going to be straightforward. First, it's going to be Spring component, and that component needs JDBC client. You can use Hibernate, you can use Spring Data, it's up to you. It's just my preference. We want this to be auto-wired. Also, we need to use the embedding client, and this is the new bean that was introduced by the SpringAI framework. We also want to auto-wire this one. I want to generate my embeddings. This is what was generated by Copilot. My implementation is going to be a little bit different. Let me use query, and I want to get their row set. It's going to be our result. And if you remember, yeah, we need ID because then we need to write back our generated embedding. And also we want title and overview for every movie. What we do next? We want to iterate through the result. Let's see what Copilot suggested. We need to get the ID. Then we need to get the title. We need to get the overview. This implementation is not what we need. I want to use a combination of title and overview for my embeddings generation. Okay, and then I am using embedding client embed method where I need to pass this text, and in return I will get a list of doubles, an array of those floating point numbers, and let's call it embedding. Next, I already see that this suggested method that updates embeddings in my database looks wrong. Let's rewrite this implementation that was suggested by Copilot. What I will do instead, let's try this one. I want to update movie. The name of my column, though, if you remember, overview vector, we will assign it to this embedding parameter, and that needs to be the ID of our row. So then we are passing embedding, and we are doing this update. One thing, you cannot pass this list of doubles, but what will work is one of the options. Just translate this to string. Next, let's introduce some counter so that we know how many embeddings were generated, because it's not an instantaneous operation. And we will be printing every 10, not every 100, but let's do every 10 generated embeddings. What else? Let's do this system out println generating embeddings for movies. Sounds good. What I want to do next? I will use Spring command line runner, implements command line runner. I want this logic to be executed at least once. And if you remember, we need to implement this method to run that will be executed by Spring. What it needs to do, it just needs to call to this generate method. So that's our implementation, my friend. That's all you need to do. You need to read all your rows that store that text data that needs to be translated to embeddings. Then you read every row, and for every row, you execute this method using SpringAI here. SpringAI will connect to OpenAI embedding model that runs somewhere in the internet, and then it will return an embedding for you. Once this happens, we will be storing this embedding back into our database in the overview vector column. So it will take some time, it's not instantaneous operation, but let's start our backend. And first it's going to be a good check if this implementation is complete, because I might have missed something. I want to stop the currently running instance of my Spring Boot application. And when I restart, it should execute my embeddings generator. Classics. We've got some exception. Let's take a look at it. Yeah, we've got this issue. The column indexes is out of range. Let's check it. Certainly, this one expects us to use this approach when we have these placeholders, not named parameters. Let's do it this way. I think the param method, yeah, it accepts my format. Good. Classics, right? Always get some exception. Let's restart, giving another try. So why don't we try to debug and troubleshoot all the possible issues together? Okay, let's see what's the next exception. Yeah, it says that you need to rewrite, yeah, column overview vector is of type vector, but the expression is of the type character line. I think I know what's happening. So here we're passing these embeddings following this approach. And if you do it this way, what you need to do is you need to convert your parameter to the vector type explicitly. So I bet that this should solve all of our problems. Let's run the backend one more time. And finally, you see that we have started generating embeddings. You've got two exceptions, but we managed to fix them. At least now you know. If you come across something comparable, then you will know what's happening. Waiting. But it's not generating anything. According to my application logic, it should have already generated certainly at least 2 embeddings, but I don't see this message. And I think I know what's happening. I forgot to provide my OpenAI key. So generally speaking, there are some long timeouts by default. What I need to do is to pass this environment variable. Let's do this, export OpenAI API key. And now I will pass this variable, but I don't want you folks to see it. Alright, we are back. I have successfully provided my API key through that environment variable. And hopefully that was the last issue that I had to address. Let's repeat Spring Boot run, connecting to the database, and we have started generating embeddings. Oh, wonderful. We have already generated 10 embeddings, 20, and it will continue for several minutes. Back to data grid. How many movies do we have in our database? We have 2,835 movies. And also by using this method, you can track the status of this embeddings generation, where overview vector is not null. And you can see that this number keeps changing, keeps changing, keeps changing. So I'll see you in a few minutes once the generation process is over. The generation process is over. Let me execute this method one more time. Yes, we generated 2,835 dimensions. That's how many movies we have in our database. Back to Visual Studio Code. You no longer need this embeddings generators. You can remove this method from here so that the next time when you start your Spring Boot application, you don't want this generation process to start from scratch. From the logic implementation standpoint, as you remember, the application presently uses the full-text search-based implementation to come up with those movie recommendations. And this is exactly what we want to change with our GenAI capabilities with the vector similarity search. Which means that the first step is that we need to get an instance of the embedding client that is part of the Spring AI framework. We want this to be auto-wired. Let's pass it with the constructor. Done. And now I'm replacing this full-text search-based implementation with the similarity search. Why I don't want to implement this method from scratch? because I'm lazy. We've already done this in our previous video, so if you haven't watched it yet, then you will be able to take a look at it later. But as a quick reminder for everyone, how the vector similarity search works, we are going to find the distance between the overview vectors of our movies and the user prompt vector. And then those that are closest, they will be considered as the most relevant. Now I want to get this prompt embedding. How do I get it? You are using the same approach that we used for the embeddings generator. I literally will copy and paste this line and add it here. The difference is that I need to generate an embedding for the user prompt, and the current implementation expects the following variable. So it's all done. Speaking about the similarity threshold parameter, this is one of the parameters that you need to fine-tune and test depending on your embedding model. I want to get all of those movies from my database that are at least 40% close or relevant for the user prompt. And this is how we use it in here. You want to get all the movies that are bigger or equal to this similarity threshold. And this threshold is the value from 0 to 1. Closer to 1 meaning more relevant and more accurate. But this one is good enough for me. So that's the complete implementation. Let's go back to our browser, that's our application, and presently I'm still running an instance of this application that relies on the full text search. If I ask to find the recommendations for the following prompt, it's obvious for us humans. You know that no, the full text search implementation will not be able to come up with those suggestions. But let's copy this one. We are returning here and we want to restart our backend. All right, starting it. And this instance of the application is going to use the similarity search, OpenAI, and embeddings that we have already generated. It's up and running. Now if you try to click the search, you will be redirected to the sign up screen because I'm using Spring Security. I am signed in, and now if I repeat the same search a long time ago in a galaxy far, far away, guess what? You are getting the right answer, and this is how you can build GenAI applications. So, job done, my friend. How do you like this, my friend? Isn't it cool? It literally took us a few minutes to create an embeddings generator using the Spring AI framework and an OpenAI embedding model. And as for the next steps, if you have not already done this, go ahead and watch our first movie where we were building this movie recommendation service from scratch. You're gonna learn a ton. In the meantime, keep mastering databases and see you soon. Bye bye now.